We need to talk about what that capital M means. You've got a whole blank page on the back of your lab. Please turn to that. As I was saying earlier, this is the way, especially in high school chemistry, and even your first year of college chemistry, the concentration unit you're going to use most often is this idea of molarity. That's what the capital M stands for. Okay, I'll show you what that. I'll write that up here. And what molarity refers to is moles of solute per liter of solution. Now, I'm finding, as I've talked to my previous class, that not all of you have spent a lot of time talking about solutions and the components of a solution. Some of you have, but mostly not, or you don't remember either way. So let's talk about this a little bit. One point of emphasis I do want to make, though, is if you can't screw this up. This is very simple stuff. I mean, you guys have seen very similar equations. Speed equals distance divided by time. Density equals mass divided by volume. You see where I'm going with that? You guys know how to do this stuff, okay? But the one thing that you can have a tendency to mess up is right here. We don't measure volumes in this class very often, if ever, in liters. What do we usually measure our volumes in? Milliliters, right? Typically, or cubic centimeters, which is the same thing as a milliliter, right? Okay? So, where I'm going with this is, in order to use this equation, your volumes have to be in liters. So you're going to have to be very adept at changing back and forth between milliliters and liters. Does anyone remember that relationship? That is precisely it. I'll let you worry about making those interchanges, but I'm telling you right now, if you're using this equation, please don't forget to change to liters or back to milliliters, depending on what you're trying to do. Okay? Now, it does have a handy-dandy little equation. Like you said earlier, someone saw earlier, a lot of times most stuff you're going to get from me will have that M capitalized and italicized. I don't know how to do italics on writing, so imagine that's italicized. And it'll look like this. So there's the equation that you're going to end up using. Molarity equals moles over volume. What's your volume have to be in? Liters. Okay? Your volumes have to be in liters. Okay. Anyway, we can rearrange this equation. In fact, this is where, remember I told you about a lot of times with our stoichiometry problems, we're either going to be given quantities in moles, or somehow come up with moles, or asked to find moles. This is why. Because not everything we're going to use in chemistry comes as a solid in which we're going to measure its mass. Sometimes there's solutions. Okay? And so how can we find moles from here? Now, I taught you guys how to rearrange equation. Let's see what happens. If I were to rearrange this equation and solve for moles, what would I get? Jordan? No. Molarity times the volume. Remember, we take the thing we're looking for, get it by itself. We need to get rid of the V. The V is in the denominator, so we move it to the other side and put it in the numerator. That's the handy way to convert to moles with a solution. Now, what if, like in tomorrow's lab, we need to find the volume of a quantity when we know the number of moles and we know the molarity? There you go. Molarity over what? Moles, you say? Yep. Nope. Yeah, you just did what most people do. You've inverted it. Moles over molarity. Here's why. Remember, we're solving for volume, so it has to be in the numerator. So I move it into the numerator on the other side. Now I need to get it by itself. We take the molarity and put it there. Done. Okay, so there we go. So those are three forms of the equation we're going to use. What is this solution thing? And this is where we had some problems with my other class, so let's talk about that. Does anyone know a definition of a solution, just out of curiosity? One that would be chemistry practical. Say this again? Well, yeah, but what does that mean? Two or more. It's a mixture. There we go. It's a mixture. Good. What specific type of mixture? And when I say it, you're going to, Shelby might have a chance. What does the word start with? What letter? It starts with H. It's okay. You're way further along than many. There you go. A solution is a homogeneous mixture. So if you've ever seen, or homogeneous, it doesn't really matter how you say that, if you've ever seen the phrase homogeneous or homogeneous mixture, you have just defined a solution, a true solution. Now you can have other mixtures, but they might be called a heterogeneous mixture. So, what are the components of a solution? There's two parts to a solution. Anyone know what those are? It's okay. Solute and solvent. Usually, the solute is usually, not always, I'll put greatest. Usually the component in the greatest amount, not always, but typically the component in the greatest amount, and the solvent is usually, and I emphasize that again, the least. Oh, I lied. Gosh, that was dumb. Sorry about that. I'm going to check back with you, make sure you have this right. The solute is usually the least amount. The solvent is usually the greatest amount. There are exceptions to that, but for now we're going to go with that. Now, there's a lot of different things that can be both solutes and solvents. Victoria said earlier the saline solution that you might use for your contacts or something like that. What does the word saline refer to? Do you know? Yeah, the saline refers to salt. So basically you can make your own contact solution at home. Just put some sodium chloride and some water. You've got yourself a little saline solution. Okay? But anyway, a great example of this would be, well, you guys have all made homogeneous mixtures before, I'm going to guess. Has anyone ever made Kool-Aid? Right, okay, that would be a great example of this. What would be the solute when you're making Kool-Aid? The solute would be the mix, the Kool-Aid mix in sugar, right? Whereas the solvent would be the water. You guys following there? Okay. Now, how much time do we have left? Okay. We can vary the concentration of that, though. We can put more or less amounts of Kool-Aid mix and or sugar in there, right? We can have higher concentration, lower concentration. The big thing, though, is it's a homogeneous mixture, which means if I gave every one of you a little cup and made up some Kool-Aid, make up the Kool-Aid that you want. Grape Kool-Aid, okay? And I made it according to the directions, not the way you guys make it sometimes, okay? And I went around and poured each of you a little bit of that Kool-Aid. Would you all have the same experience? You absolutely would. There would be the same amount of Kool-Aid mix and sugar in if you make it correctly, David. Not with 4 cups of sugar.
Well, the one at the bottom is going to be like this.
No, it won't. if it's made correctly.
Still, it's gonna like go down.
No, it won't, David, and there is the whole point of a solution. A homogeneous mixture is the same throughout, no matter what. Okay, have you ever had a soda before?
Yeah.
Like Pepsi?
Yeah.
Is it different at the bottom? Why not? It's a homogeneous mixture.
But hold up, we're talking about Kool-Aid.
Kool-Aid that you make appropriately without 5 extra cups of sugar.
Well, if it's your rest, it's gonna like. I'm gonna do this at home. I'm not sure.
Excellent. Moving on. Okay, so yes.
Okay, so in Miss Gruffin's class, we did this thing where we had nuts and bolts and
Yeah.
we had to separate them and make it mixtures and solutions
Yeah.
and stuff. So is that?
No, because those are all heterogeneous.
Yeah.
Because you get different. For example, if I had that big mixture of nuts and bolts and came around and poured everybody the same mixture, some nuts and bolts in everybody's little cup, would everybody have exactly the same number of nuts and bolts?
Is that cookie dough?
Okay, cookie dough,
I
right.
don't know why I just thought of that.
I know, like chocolate chip cookie dough or something like that. I don't know, but we need to speed this up because you guys have to clean beakers yet. Yes?
I was just going to say, isn't it if it mixes perfectly, there's no chunks or anything in it, then it's a homogeneous mixture to all mix perfectly.
For example, has anyone ever seen Italian salad dressing? And if you just pulled it off the shelf or out of the refrigerator and poured everybody a little bit, would you all have the same experience? What would the first people be getting mostly? Oil. What would the next group of people be getting? Vinegar and water, as it turns out. And the last people would be getting all the seasonings and spices that are in there, right? Even if I mixed it up, would you all get exactly the same thing? No, because those spices and stuff are distributed a little bit differently, right? So that would be a heterogeneous mixture. All right, so you guys are clear on what this is, right? Usually in high school especially, the solvent is almost always going to be water. The solute's going to be other things, okay? Anyway, you have a pre-lab to do for tomorrow. There are 6 questions. 6 questions. I'm telling you right now, you know the molarity. What's the molarity going to be? 3 molar. And then they're going to be asking you to calculate either moles or volume from that. So that I will grade the pre-lab before we start the lab tomorrow. It takes me 2 minutes to walk around the room and grade those all. Okay, at this point in time, you guys need to know who your partners are, where you are, and you need to clean and rinse a 150 milliliter beaker with deionized water. Your partners are as follows. Station 2, Mallory and Danae, go. Station 3, Alex and Braden, go. 4, David and Victoria, go. 5, Shelby Jordan, go. 6, Lauren Usman, go. Usman, go. Get a beaker, get it cleaned up. 7, Josiah Maisie. 8, Brandon Josh, go. Carter and Matt are 9. 10, Elizabeth and Morgan. 11, Allie and Maddie, go.